Hi everyone, welcome to chapter 15, which is weathering and mass wasting. So we're going to talk about how landscapes get eroded, and we're going to talk about erosion for the rest of the semester. And we're also going to talk about how then that material then gets moved. So here is a picture that I took driving up the 67 to Ramona, and so you can see the landscape there, lots of rocks up on that hillside. So we're going to want to know, like, how did that landscape form? What was happening there? So the first term that you need to know is called denudation. And so that is the flattening or stripping of a landscape, which is always happening, right? The planet is always kind of erasing itself and reforming. It happens in 3 steps. The first is weathering, and that's when big rocks are broken into smaller rocks. We can see in this illustration that's happening due to rain. Mass wasting, we'll talk about different types of mass wasting, and that's when rocks move downhill, sometimes slowly, sometimes very rapidly. And the third part is erosion, and that's when rocks are removed from the area by some force. Very often that force is water. So there are 2 types of weathering agents, which I'll go through in more detail, but the first one is mechanical. And that is a physical type of weathering. We can see here these boulders in New Zealand. They're very round. They have been rolled around by the water, banged up next to each other, and weathered that way. So some type of force causes the rock to disintegrate. And the other type of weathering is chemical, and that's where some type of reaction dissolves rock. And so here's a picture from Sunset Cliffs. You can see all of those pot marks in that rock. Water settled into that rock and it eroded away by a chemical process. So mechanical weathering agents include any kind of blunt force that weathers rock from the outside. And that includes stuff that gets inside of rock joints, frequently water, that will cause it to weather. There are a few types of mechanical weathering. The first one is frost wedging. Frost wedging can only happen in places where it gets cold enough for water to freeze. But basically you have water that gets in the joints, which you can see at the top there. That water freezes, and then the expansion that happens when that water freezes pushes that rock apart. And this is repeated many, many, many times over. So water will continually get into that joints, freeze, push apart, thaw. Water will get back in, freeze, push apart, and thaw. And again, only happens in places with freeze-thaw cycles. So we can see frost wedging in San Diego County, but we got to be at a higher elevation to see it because down at a lower elevation, it never gets cold enough for that water to freeze. And so here are some examples of frost wedging. One I took at a friend of mine's house in Hamul, where it does get cold enough to freeze. You can see that rock there on the left. Some water got in there, froze, and then pushed it apart. And another picture is one that I took in Zion National Park. Water continually getting in there, freezing, pushing it apart. The second type of mechanical wedging is something called salt wedging. So you get salt crystals that are left behind from the water in the joints. After that water evaporates, that salt is left behind. And it accumulates over time. It's a slower process. And the heat, so salt crystals are heated, they expand. And so it's seen often at the bottom of sandstone cliffs. So we can see from Mesa Verde National Park in Colorado, there was some salt wedging that happened there, also in Zion National Park. Also seen along shorelines because we have salt that's being left behind by that ocean water. And the third type of mechanical weathering is exfoliation, and you're going to watch a short video of exfoliation in action. And so you can see a lot of evidence of exfoliation in Yosemite National Park if you've ever been there. But basically what you have happen is you have this harder rock that's down here. It was being pushed down upon by all of these outer layers that then are removed by some type of weathering. And so there's less pressure holding that rock together. and so it will expand and kind of flake off. And again, you'll watch a video that kind of shows that happening. It's a pretty cool video. And so that rock peels off like layers of an onion, which we can see here in Yosemite National Park. Chemical weathering is a chemical reaction that weakens the structure of the rock. We usually see this in terms of these little kind of pot marks that are happening. It is more common with water, often seen as circular holes. And so with water, that happens by hydrolysis. So that water in the rock dissolves some, or that water on the surface dissolves some of the minerals in the rock. And the crystalline structure of that rock breaks down. That should say down, not dow. And small pieces are then removed and washed away. So if you go to Sunset Cliffs in San Diego, you can see lots of examples of hydrolysis. Another type of chemical weathering is oxidation. So oxygen will bind with certain minerals in certain types of rock, and those oxidized materials are then softer. Think about it if you have metal that rusts, right? That metal gets much, much weaker, and tiny little bits of it will flake off because of that. It especially happens in iron-rich rocks, which you can see here in Arches National Park. Excuse me, I'm a little fast with my button today. So you often get this, it looks like a very kind of reddish landscape from that oxidation happening from that iron, right? Just as you would have happen in a nail here. Mass wasting, which here is an example of mass wasting, is weathered material that is moved downhill by gravity, right? It's always by gravity, right? Gravity always wins, which I'll talk about a couple of times, but you get material up here that was weathered. Here it collapsed onto a road in the form of a rock slide, but that material gets weathered to the point that it loses its structural integrity, and then it will fall downhill. So there are some things that influence mass wasting. I want you to look at the catchment basements in Los Angeles, which I'll talk about in a second, but I'll give you a link to some Google Maps imagery where you can go in and kind of see where they are. But basically, things that influence mass wasting are gradients, so how steep a slope is, right? If a slope is really steep, the gravity is going to be more extreme there, and so it's going to roll downhill. So again, how steep. Consolidation, which is how weathered the rock is. The more weathered the rock is, the more mass wasting you're going to get. And water content. The more water usually means more movement. It acts as a lubricant to push that material downstream. So in Los Angeles, they have catchment basins in order to collect things that roll downhill so that they don't kind of disturb people's houses, because sometimes the stuff that's coming downhill can be quite large and quite destructive. So again, the water content adds weight and adds lubrication. It makes it heavier and it makes it easier to move. And the last is vegetation. So plants slow down mass wasting. We plant plants all the time in order to prevent erosion. Those plant roots can kind of dig down deep and hold stuff together and keep it from eroding more quickly. So there are a few categories of mass wasting. Some that are more extreme, some that require more water and less water. You don't need to know all of these. I will go over the few that I want you to know. So the first one is flows, and those are a result of too much water and makes the earth move like a fluid. So more water equals more flow. If it's drier, they are slower. Mud flows are very wet, fast-moving debris, as opposed to earth flows, which are drier and slower. And so here is an earth flow, right? This is a mass wasting event. It's pretty small, but there has been some water here, not a ton, and it's caused this hillside to just slide off and roll downhill, as opposed to a mud flow. This is one from Switzerland that was quite devastating. Tons of water. That earth is just moving like liquid downhill. Lahars are a special type of flow that happens from a volcanic eruption in some place that is cold. So you get a volcanic eruption that happens and it melts the snow, mud, and rocks and debris quite quickly, and it causes them to roll downhill. So another hazard of being near a volcano, if it's cold and you get an eruption, you can get this flow that happens because of it. The next is slides. And so this is caused by weakened rock, and the earth then moves like a solid. So it's not moving like water in this case, it's moving like one solid block. You can see a slide that happened here. This whole hillside came down. And so here's an example of a landslide that happens, right? Everything comes down together as one big solid piece. Water can help with this. It can lubricate it and allow it to happen quickly, but it's not flowing like water. Human activities make slides more likely. We build stuff on steep slopes that then can cause it to kind of break apart and weaken that structure. And so here's some examples of landslides that can be kind of extreme. You can see here there was a road there and this whole thing fell down. But notice how these trees are still upright, right? This thing fell as one big piece. They can move a ton of debris really fast, in this case, destroying many houses. Here is an example of a landslide that happened, right? We like to build houses kind of on these steep slopes that especially overlook the ocean, but they can be quite dangerous if they're not built properly. Rock falls are when weathered rock falls very fast. They are very common in Yosemite National Park. They can be really, really damaging. You can see this rock fall that happened in Italy came through right alongside this house, destroyed part of the structure. The blast from the displaced air as the rock lands can snap trees, which has been seen in Yosemite. They used to allow people to camp right up against the walls in Yosemite Valley, and they've pushed that back due to rock falls that have happened there. In 1996, a rock fall happened, took out 1,000 trees, and unfortunately killed one person. Right, and so here you can see all of these snap trees that happen from this rock fall coming down in Yosemite. We can also see, this is a picture from Pueblo Bonito and Chaco Canyon in New Mexico, which I highly recommend visiting if you have a chance to. This is a prehistoric Native American village. And so you can see things like this, right? This guy here is going to eventually weather enough that it's going to fall. And you can see here rock falls that have happened that have destroyed parts of these structures. So one of my favorite examples of a rock fall, if you're from the Northeast, from New England, you might have heard of the Old Man in the Mountain. New Hampshire is known as the Granite State, lots of granite in New Hampshire. But the Old Man in the Mountain was quite a beloved feature. You can see him right here. I did see him. I hiked and saw him up in the White Mountains in New Hampshire when I was a much younger person. It's even on their license plate and on their state quarter, right? The Old Man in the Mountain. But he fell down. In the middle of the night, there's no pictures of him falling down, but eventually he weathered enough and came down. And the thing here is gravity always wins, right? These things are always going to be eventually eroded and fall down. We also have human-induced mass wasting and erosion. And so studies suggest that humans cause 10 times as much removal of material than natural forces. We do this a lot through development and also through mining. So again, construction and mining, we speed up these natural processes that would have happened on their own, but we do them much, much faster, often to our detriment. So this is a picture of mountaintop removal, which became a very popular way of getting at coal. Especially in Appalachia, which Rather than sending people into mines to get the coal out, they would actually blow the top off of mountains with dynamite and then remove the material after that way. It can be really hazardous to local waterways. You get a lot of minerals and selenium and stuff that are polluting local waterways. So it is very, very environmentally destructive. And that is the end of weathering and mass wasting, a much shorter chapter than the previous one. After this, we're going to move on to fluvial processes or rivers. So I will see you back here for that.